In this video, I'm going to talk about determining the type of a solution to a system of equations. You should have gotten the reading either from the site or from in class. You should have gotten that reading and made sure and read through that first. So that kind of explains and sets up the vocab and the different types of things we're going to talk about in this video. So just as a recall, remember that we can determine what type of solution we have by looking at first the slope. And whenever the slopes are different, we can already state the lines must be crossing or intersecting, and there's one solution. If the slopes are the same, we also have to look at the y-intercept. And if the slopes and the y-intercept are both the same, we can say then that means the lines are the same and they overlap and have infinitely many solutions. Or if the slopes are the same but the y-intercepts are different, we can assume that they are parallel. Same slant, different starting points, and there is no solution. Please remember they do need to be in y equals mx plus b form first. So in each of these following examples, there are 3 of them. We're going to, without graphing, determine the type of line it is. Is it intersecting? Is it the same line? Is it a parallel line? And then we're going to determine the number of solutions. 1, infinitely many, or none. I do want to point out if there is one solution, we will not take that extra step of finding it. So please remember that that will kind of be the next step we're going to take, is once we know that there's one solution, how do we figure out what that one solution is? So that's going to be in your next objective. So for now, we are just going to determine that yes, there is one solution, or no, there's infinitely many or none. So looking at the first example, I noticed that neither of these equations are in y equals mx plus b form, which as you saw in the reading, it does need to be in y equals mx plus b form first. So I'm going to change each of these to y equals mx plus b form. So in the first one, I'm going to subtract 6x from both sides, giving me 3y equals 3 minus 6x. I'll divide both sides by 3. Y equals 3 divided by 3 becomes 1. 6 divided by 3 becomes 2, so I get 1 minus 2x. So I'm going to go ahead and anticipate that I'm going to want to know my slope and y-intercept. I'm going to say my slope is then negative 2, and my y-intercept is 1. Now I'm going to do the same for the second equation. So I'm going to start by subtracting 2x, giving me y equals negative 1. I have to do it to both sides, so minus 2x. And then I don't have to do anything further. Y is already by itself, so I'm already ready to state my slope and my y-intercept. My slope, of course, is in front of the x, so it's negative 2. My y-intercept is negative 1. So now looking at what I have here, I see that my slopes are the same. So I do know that I either have infinitely many or no solution. So then I look at my y-intercept, but I notice my y-intercept is different. So if I write that down, I have same slopes and different y-intercepts. Well, I know that implies that these two equations have graphs that have the exact same slant. However, they have different starting points, which tells me that these guys are going to run parallel to one another. So I have parallel lines, which means by definition they will never intersect, and there is no solution to this system of equations. They do not have any point in common. I'm going to go ahead and look at example 2, and I'm going to do the same thing. So again, I'm going to start by changing to y equals mx plus b form. So on this first one, I'm going to subtract an x from both sides, giving me 2y equals 4 minus x. I'll divide by 2, giving me y equals 4, excuse me, not 4. Oh, it won't let me get my eraser. So I'm just going to have to rewrite over that. 4 over 2 is 2 minus x over 2. And then I'm going to go ahead, and now that y is by itself, state my slope and y-intercept. Well, remember, if there's nothing written in front of an x, it means there's a 1 there. So I'm going to go ahead and say my slope is negative 1/2. And my y-intercept is 2. Looking at the next equation, I'm going to subtract 3x from both sides, giving me y equals 3 minus 3x. Y is by itself, so I can say that my m is the negative 3 in front of the x. My b is 3. So right away I notice they have different slopes, and as soon as I notice the slopes are different, I don't need to do anything else. I do not need to look at their y-intercepts. So I'm going to go ahead and say different slopes. I know then that they intersect and there is one solution. Or intersecting lines with one solution. Looking at the third example, if there's one you want to try, this would be a great one to try. And now that you've paused the video and tried it on your own, let's go ahead and see how you did. So first, getting y by itself, I'm going to take my first equation and subtract 2x from both sides, giving me 4y equals 8 minus 2x. Then divide both sides by 4. They cancel here. And y equals 8 divided by 4 gives me 2 minus 2 over 4. I know those can both be reduced by 2. So I'm going to go ahead and say 1x over 2. And I'm ready to find my slope and y-intercept. Slope is, of course, in front of the x, so negative 1/2. My y-intercept is 2. And now I want to look at my second equation. Again, isolating the y, so I'm going to subtract a 4, giving me negative 2y equals x minus 4. Then I'll divide by negative 2. They cancel on the left, and I get y equals x over negative 2. Negative 4 over negative 2, and negative over negative is plus. 4 over 2 is 2. And I'm ready to find my slope and y-intercept. Well, again, remember if you have just an x, it's like there's a 1 over it, in front of it, excuse me. So I have 1 over negative 2, which it doesn't matter where the negative is, so that's the same thing as negative 1/2. My slope, my b, is 2. So notice that my slopes are the same and my y-intercepts are also the same. So I have slopes and y-intercepts are the same. Well, if they start at the same spot and rise over run at the same rate, they should have all points in common. So I'm going to go ahead and say these are the same lines, and therefore there are infinitely many solutions. With infinite many solutions. So the big thing to remember is this chart here. You now have it here in your notes as well as in your reading. So make sure that you bring these notes as well as the chart, whether from the notes or from the reading with you, so you can use it as a tool as you do your practice in class.